Hello, I'm EttoCraft, and today I'm going to interview the Bath Rocketry team. Could you please introduce yourselves?
Yeah, so I'm Andrew. I'm the team lead of the project.
I'm Ben. I'm the mechanical technical lead of the vehicle.
And I'm Clara, the marketing leader, and I'm also working on the hybrid engine.
We started as a team back in 2017, before all of us were at uni, the Spaceport America Cup. So the team went there once, I believe, in 2018, and had our first successful launch. We weren't able to recover that rocket, but it was a good start. The next year, unfortunately, the competition was cancelled by COVID. And then since then, we've been going to the European Rocketry Challenge. So we had our first launch there in 2021, which was a fully successful launch. We got the rocket here, actually. And then 2022, we had a failure to get off the launch pad, which I'm sure we can talk about later. But yeah, that was unfortunate. And we're now we've come back 2 years later, hoping to remake the team a bit. There's a whole new load of people working on it. We've got some pretty ambitious new projects that we've been working on, and yeah, hoping to get back to EuRoC this year.
Will this year's EuRoC rockets have the same payload with the helicopter as the one from 2 years ago?
Sadly not, no. Yeah, we all sort of wish we still had that. The guy who designed it was 3 years ago now, has graduated. We don't have the design. So unfortunately, not this year. There's been some talk of him coming back and helping us redesign it and build it again, but that's something to discuss in the future. Yeah, our payload this year, it's sort of a new thing to try and get more people involved in the team. We've got a load of first and second year students at the uni to design it for us. So yeah, that's a different project this year.
And what would the new payload be?
The plan right now is to do some testing on the effects of launch on 3D printed parts. So essentially sort of stress analysis and temperature analysis of the 3D prints throughout the launch, because we're using a lot of 3D printed parts on the rocket. So the design has sort of just started on that.
I mean, the vehicle this year is going to 9,000 meters, hopefully. And so it's, represents quite different flight conditions that we've had in the past. So some of the first years were quite curious about how vibration and temperature principally will affect the strength of 3D prints. So that's what they wanted to investigate.
Yeah, and it's quite nice because we've struggled to get first and second year students involved directly on the rocket in the past. In my first year, I worked on like a mini rocket outside of the main rocket. So this is good to get them involved in the actual project. A sort of interesting area of investigation. It'd be good to have some data to say, yes, it's fine to use 3D printed parts, or no, it's not. We'll see how that goes.
How did your team start and grow?
Yeah, like I said, we started with 6 members back in 2017. I think they just started because there was no rocketry team at the uni or any space-related projects, and we all do an aerospace degree, so I think they wanted to have some space stuff as part of the course, so they started the project, and it's been growing since then. So we started with 6 members. A couple of years ago, I think there were 8 members, and now we've got about 20 full-time members and a number of other people who sort of help out. Yeah, it's growing. It's growing consistently. We're quite looking forward to seeing who will get involved next year.
One of the main projects that kind of get people involved is a piece of coursework as part of the degree called the Group Business Design Project. So, and all 3 of us on the call right now, that's how we got involved. And most of the people this year, that's how they first got involved with the team.
How is it to study in your university?
So we all do the same degree, Aerospace Engineering. We're all final year. I think Bath is quite a practical university. I mean, obviously having projects like this is really good. Also, it's quite unique, at least in the UK, that we can do this project as part of our degree. So Ben, for example, is doing this as his dissertation. He's making the recovery system, and we've got other people on the team doing various bits of the rocket as part of their degree course, which is really good.
Well, about life at university, because I'm originally from France, not from the UK. I think it's a very friendly university. A lot of international students are studying here. So it's a very, very friendly environment, very motivational as well. And working in the workshop with everyone, it's very nice as well.
Yeah, we've been lucky. The uni's recently upgraded us to a new workshop, which is a much nicer space to work in. Much bigger too. Nice. The uni is pretty generous.
What are your job opportunities after you finish university?
I think we're all looking at going into the aerospace industry. I know Clara and I have both applied for the ESA graduate scheme.
Yes, for the same positions as well.
Yeah, against each other, but fingers crossed one of us gets it.
Yeah, well, maybe 2 of us. We'll see.
Maybe 2. Yeah. I think the uni itself is quite it's got quite a lot of links with the industry, not necessarily space stuff, but with the aerospace industry in general. We've got a lot of people who go to big companies like Boeing and Rolls-Royce, and then the rocket team itself has fairly decent links with the space industry. We've got alumni in, for example, Orbex, which is a rocket company in the UK, up in Scotland. Team members who did placements in Rocket Factory, Augsburg in Germany. Got some links with the industry.
Basically, all of the team members last year went on to go working in space companies. So it does feel like the team is quite successful at getting people into working in space.
Well, just the location of the university in itself, because we're very close to Bristol and Filton. So there are a lot of big aerospace companies there. There's Airbus, Boeing, Rolls-Royce.
Yeah, we were lucky. Someone on our course organised a tour of the Airbus facilities. The occasional speaker to come from the big companies and talk about jobs and opportunities. There's a decent amount of stuff happening in the UK at the moment. There's quite a lot of satellite companies recruiting currently. We've got a couple of launcher companies based in the UK as well that are doing a lot of recruiting. So I think it's quite a good time to get into the industry.
And also to go back to what we were saying about the group business and design project, is that some of the assessors are professionals from the industry.
Yeah.
So that was also very good to have feedback from. There was an engineer who worked on Concorde.
Yeah.
So that was pretty cool, and very useful to have this type of feedback.
Yeah. We had support from a guy who used to be like the project manager, Eurofighter Typhoon. Yeah, it was interesting.
What's the experimental rocketry community like in Britain?
Well, I guess similar. It's growing quite rapidly. As you probably know, there's quite a few teams now in the UK hoping to go to EuRoC. I think when we first went in 2021, it was just us and a couple others, and now there's a good 10 teams with 10 universities with rocket teams. Sorry. So yeah, there's a lot going on. We're hoping for a UK-based competition at some point in the future. We'll see.
I mean, even in the last 2 years. So last year we took part in a competition called Race to Space, which is an engine testing competition, and it was the first year of it was last year, and we were one of 4 or 5 teams. It was very, very small competition, so there was only 4 or 5 engines being tested. And this year we're going to go back, and there's at least 10 different entries. So it's growing incredibly quickly.
There's some really cool stuff. I mean, we'll talk about what we're doing I think later on in the interview, but there's other teams designing biprop engines, 3D printing,
cooling.
Regeneratively cooled engines, and there's quite a lot of different stuff going on. It's quite interesting. Lots of competition.
What are your team's goals?
Yes, the main one is obviously get into the European Rocketry Challenge. The team was quite disappointed last year to not get in. We think the main reason was a lack of ambition. So we've gone the other way this year. So we're aiming for 9,000 meters, which the team hasn't gone for in the past. We have our new hybrid rocket engine, which we have been designing over the past couple of years, tested it successfully at the Race to Space competition. So we will be entering the student designed engine 9,000 meter category. In terms of roadmap, we're currently in the sort of late stages of design. So the majority of the rocket is designed, but we're waiting for a few smaller things. So there's someone on the team doing engine cooling. There's a guy on the team doing like the plumbing for the engine that still needs to be sorted. Ben's working on the recovery system. But pretty soon we'll be in sort of full manufacturing swing, and then applying for EuRoC, hopefully get in, and then manufacture over the summer. Got quite a lot of testing to do as well, especially on the engine, as part of EuRoC and the Race to Space competition. So that's the sort of broad roadmap.
I guess our biggest medium-term goal is getting the engine built and test fired without any significant anomalies. At that point, a lot of the other challenges the team faces are relatively, in the context of rocketry, relatively conventional challenges. But having the engine work successfully without burning through our insulation, which was our major issue last year, is kind of the main goal for now.
That we did start manufacturing some small pieces. Like the airbrake systems, and we are getting prepared for the manufacturing of the fuselage. We
started manufacturing the airbrakes, which are actually almost ready for assembly. Similar for the recovery system, we just need a few more parts. And then Ben's going to manufacture the parachute himself as well. And we've started manufacture of the molds for the fuselage. So the fuselage is a composite fiberglass fuselage. So we're going to be laying up. We 3D printed the molds. We're prepping them to do that in the next couple of weeks. And then the other active projects, I guess, apart from the sort of the main structural design, is payload, engine cooling, engine plumbing.
You said that you're making a hybrid engine. What is its fuel and oxidizer?
The fuel that we're using is a paraffin wax. We are also investigating the use of using beeswax. The university is really keen on green-based initiatives and having a sustainable and renewable fuel like beeswax that the university really loves. So we're investigating that. And then our oxidizer is nitrous oxide.
A recent challenge is that our manufacturer for the fuel grains, the solid bit of the fuel, has pulled out due to time constraints, having to consider manufacturing our own fuel grains. So we're looking at building a centrifugal sort of spin casting rig that we use to cast our own grains. So that's, well, we just started working on that a couple of weeks ago, but hopefully we'll have that up and running soon so we can start manufacturing grains and test them at the Race to Space competition.
Well, almost all the EuRoC teams make their own grains.
Yeah, we attempted to cast our own grains last year, and we were going to fire them, and then we encountered those installation issues, as I said before. But we found pretty significant issues with getting all of the air bubbles out.
Yeah.
So
hence the move to spin casting.
Which should be fine. It seems very feasible.
Yeah, other teams do it, so we don't foresee too many issues with doing that. Yeah, the only reason is, well, last year we just bought the grains from a supplier, which just reduced some of the work required. But this year, we can't do that. So yeah, manufacture our own ones. That's fine.
How do you recruit new candidates to the team?
Two main streams into the team. The first way is we do a big recruitment drive at the beginning of the semester, which is it's aimed at every year group in the uni. So we put up lots of posters around the uni, we do some presentations, and then we try and see who's interested, get people involved in sort of the projects that would suit them best. So third year, final year students will put directly on the main rocket versus second year students. This year we put on the payload design. And then the second stream is through this group business design project that Ben mentioned. That's how we all got into the main team. It's a part of the degree. It's kind of like the bachelor's engineering project. It takes up half of your third year of study. And yeah, a number of people will select to do the rocket team as their project, and that project runs in parallel to the main project. So they're not actually part of the team, but we find that a lot of people who work on that project then join the team in their final year, and they already have a lot of knowledge on how to design the rocket. So that's quite a good way to get them integrated, and we work with them, sort of advising them and helping them out where we can.
The students have a wide variety of what they want, like what competition teams they want to join. So this year we recruited them by, as Andrew said, putting posters all over the mechanical engineering building, the electrical engineering building as well. Like we started being very active on Instagram. But yeah, the competition is also hard between the competition teams themselves.
Yeah.
So in the workshop, we share it with the drones team, another team called the Mac Initiative. Aerospace enthusiasts have the choice between a lot of competition teams. Yeah. But we are lucky that a lot of members joined us this year.
Yeah, we've had a lot of growth recently, and we're hoping to improve our sort of handover to the next year of students this year. So the core team is made up of final year students, but there are third year students involved and on the group business project as well. So we hope to get them sort of involved in the team before we all leave, and get a good transition, so the team can work smoothly from the start of next year.
What can members learn from joining your team?
I mean, I would say the main set of skills that people gain from being in the team is learning good design practices, be that CAD or assembly, learning about different manufacturing techniques or different fastening methods. That's kind of the main thing. But the team has become recently, I would say, very proficient in modeling. A couple of the master dissertations that take place surrounding the team have been around modeling hybrids specifically, and it's something that the team has gotten quite good at. And this year we've had the benefit of matching a lot of those models to data. So those are probably the two that I imagine people learn the most. One of the reasons, just to go back to the group business design project, why it's so good, that gives you a really good solid base of how do these aero-stabilized rockets work, so that when you come into the team, you have a lot of that core foundational knowledge, so you can go straight into thinking about design rather than trying to figure out how the rockets work in the first place.
Students come into sort of their third year of uni after placement with a lot of theoretical knowledge, but the team is a great way to actually apply that to engineering, think about design for manufacture, design for assembly, which is not something that many students have thought about before, but obviously is incredibly important. I mean, I would say most of our biggest challenges recently have been because of manufacturing limitations. So that's something that's really valuable for the team.
It also teaches a lot around just project time management, budgetary constraints. Most of us, even if we've gone and done industry placements over the years, none of us have really dealt with budgets before, except for working on this project. So it lets you see them, I guess, slightly more business side of a lot of these projects as well.
But also what we did this year is organizing workshops so that we could teach the members some basics about rocketry, about rocket propulsion. And as Andrew said at the beginning, we also have this payload competition. So first and second years can get more involved, and they can develop their design conception skills. So that I think that's very useful for them, just to apply what they learn in first and second year, because especially at the University of Bath is very heavy in design. So yeah, they can just build on their on the knowledge they learned during lectures, and they can just apply it.
How do you design your rocket?
The way that we kind of started going about designing the rocket was off the back of our success at Race to Space and having an engine that works. We kind of spoke about some of the other shortcomings from the year before, where we kind of felt that we'd missed out on EuRoC because of maybe a little bit of lack of innovation from the team. So we started off as a discussion about, one, how can we kind of piggyback off of this recent success that we have, whilst also, maximizing our chances of actually making it into EuRoC. So that's at that point we decided that the main focus of the rocket this year would be using the hybrid engine. At that point, we also, because of the modeling that I spoke about before, we're relatively confident that we could use the engine to make a vehicle capable of 9,000 meters. That was the first point where conceptually we were like, we want a 9,000 meter hybrid vehicle. Then from there, it was also looking a lot about the budget that we could secure from the uni. So at that point, with the budget that we knew that carbon fiber was probably not possible. So then we've gone for a fiberglass semi-monocoque. And from there, as the designs become more solidified. So even this last couple of weeks, we've decided to integrate oxidizer tank into the wall of the vehicle. So the tank itself will be carrying the loads from the engine, how it works in real rockets. So we thought, why shouldn't we be able to do it? So a lot of it has been kind of exploring a certain development path until we get stuck, and then maybe shifting to a slightly different one until they get stuck on that one. A good amount of trial and error. If we had a slightly larger team, perhaps we could, explore a couple of these different opportunities. But instead, we kind of keep on going. But it does leave a lot of development paths for the next couple of years as well.
Yeah, it's been quite an iterative process. We've been building on various designs made over the past couple of years. So, for example, our airbrake system, which is what slows the rocket down to hit that 9,000 meter target. It was designed for the rocket. That was built for EuRoC 2022, but obviously it never flew, so we didn't get any data from that. But we built off that design and another design that we made for EuRoC during our GBDP competition. We sort of merged those designs and scaled it up. And then our recovery system is a complete redesign. But sort of the hybrid we've iterated. It's a similar Aerospike design and layout to what we designed for Race to Space over the summer, but it's bigger and it's got some improvements. So yeah, we've been sort of iterating towards the final design.
A lot of the even though the vehicle itself is quite different to anything we've done before, a lot of the actual designs are evolutions of things we've done before more than anything else.
Yeah, it's bigger. That's been a challenge. It's a lot bigger. It's 2 times longer and almost twice the diameter of all our previous rockets. So we've been running into sort of constraints with simply what can be manufactured at the university that we hadn't met in the past. So, for example, the university can only index tubes up to 1 meter long, which wasn't a problem before, and now it is a problem because our tank can only be 1 meter long. So things like that have been a challenge. But
So your engine uses an Aerospike.
I've actually got an example here. Rear section of the engine that we tested at Aerospace is actually the test article. It's partially disassembled, but I hope you can see clearly enough there the Aerospike.
Yeah, I can see it.
Added to this, or you can look on our LinkedIn. That was the result of a final year project developing that 2 years ago, I believe, or last year. Anyway, that's a graphite Aerospike that we get machined at a company nearby. We're quite excited about it. Obviously, it's new to the team, but it brings some benefits. Do you want to just talk through the Aerospike, I guess?
Yeah, I mean, we're using a truncated Aerospike, as you can imagine. At Race to Space, we were the only Aerospike engine. I believe we're possibly the first UK Aerospike, although I'm not.
Yeah, so there's another team developing one as well this year. So we'll be curious to see how they've gone about doing it.
Yeah,
I've not seen yet.
So last year at the test, one of our real big issues was there's some braces that hold on the Aerospike, and these cause stagnation points in the flow. And we saw really bad erosion of our insulating material at those points. And that's why this year we have somebody whose whole focus is insulating materials in the post-combustion chamber, because we're looking to rectify that. Otherwise, we won't be able to make our full burn times.
And you can see that's the Aerospike there. The one we've got this year is going to be, I think it's about twice as long and a little bit wider in diameter. But we haven't machined the new one yet, so that's the old one. And then that's how it's mounted in the engine. These are the stagnation points that Ben mentioned inside the engine. That holder gets really hot. So we're trying to figure out how we can cool that effectively.
I assume the holders are aerofoil shaped, right?
In the test article, they were not, just because of machining constraints. In the new one, they are going to be a little bit differently shaped. There's still some optimization going on there with the cooling.
The main concern with having them aerofoil shaped is that shape might be completely lost once you've applied the insulating material. And at that point, if we want to make them aerofoil shaped, they'll be quite thin. So we're currently kind of trying to weigh up the benefits and drawbacks between having them just a round shape versus an aerofoil shape once we have the insulation on.
Didn't Merlin also look at angled ones as well?
Yeah, we looked at angled. We looked at angled ones.
We've played around with ideas such as angling them as well to sort of get different flow characteristics, but no plans to do that so far.
How do you test and measure the performance of your engine or rockets?
Well, we currently don't have a lot of data because, sadly, the rocket wasn't able to fly at EuRoC a couple of years ago. We are hoping to get more data this time around. I guess our main source of engine data is that Race to Space competition. So the company there it's really good. They set up the whole thing for us and the other teams, and they provide data acquisition software.
The main data that we collected there last year was just thrust data through a load cell. But we also had injector feed pressure data, I believe. So this helped us model the pressure drop over our injector and how it translates to thrust. So we used that to model our efficiency, which is proving quite helpful for this year. Those are the main sources of data. On the vehicle itself, data acquisition will come through just onboard GPS circuits and IMUs, things like that.
Yeah, I'm not sure what specific data acquisition method they're going to be using on the rocket, so I'm afraid I can't tell you that. Yeah, we're hoping to gather a bit more data at Race to Space as well this year, thermal data around the engine, stress data, we'll put some strain gauges on the outside of the engine as well. The difference is last year, the engine we used at the competition was very much a test article, but this year, obviously, we're going to be testing a flight-ready engine. So there's a whole host of data we need to gather for that that we can present to EuRoC. And sort of hopefully show that the engine is safe. In terms of where that test is, by the way, I should mention it's a company called Airborne Engineering. They're very helpful in setting up all the testing and giving us the opportunity, obviously through the Race to Space competition and just general testing days when we need them.
Do you use artificial intelligence, design your rocket or something else?
We've tried to use AI to name the rocket.
Yeah.
Not that I'm aware of.
Yeah, we haven't used it in the rocket design yet. I'm sure it will happen eventually. Things like ChatGPT for sort of helping understand various concepts and sort of passing articles and things like that as part of my degree, but I don't use it a huge amount.
Pretty similar to you, Andrew. But when I'm stuck, when I don't know, when I'm not sure what I'm doing with Mathlab, I would just ask ChatGPT for some indications.
Yeah.
So the engine that we tested last year was called Hornet, and the Hornet mission patch was an AI photo.
Yeah.
True.
I think the way I could see it being used a lot is just in sort of various areas of design optimization, looking at where we can cut back weight. I don't know if there was some kind of AI that could analyze your model. I know you can do it with some stress analysis already, and you can shave off weight in unnecessary areas, but I can see an AI being useful for that, but we don't currently use it.
How do you promote your team?
We've had an Instagram account since the beginning of the team, but this year we tried to promote our event more, so the workshops. We started making some reels about the manufacturing. We also posted more on LinkedIn this year, and we are working on the making of a website. So we are working with some students in the electrical department, and hopefully it will be live in the next months.
We do have a YouTube channel as well. We haven't posted on it in ages, but there's a video there of our first competition, Spaceport America Cup. If anyone's interested in watching that, hopefully we'll get some nice videos if we go to EuRoC this year, and maybe we can make another one. In terms of other things, we've been doing a bit of outreach with local schools. Promotion and more is just sort of outreach, getting people sort of interested in engineering, which the team has done in the past. We've sort of renewed our focus on it this year because it's a good thing to do, and also because the Rece Space competition encourages it. We've been to a couple of local schools talking about the team and Rocketry, stuff like that. So hopefully some of those students come to the uni and work on the rocket in the future.
Well, I think it's because we're still a small team, relatively, because we are all endorsing some technical roles, but also some business roles. The way I see the team growing is maybe having a dedicated team.
Yeah, some of the other competition teams at the uni have this, and it's definitely something that we'd like to see the team grow into. And it would be a good way to get non-engineering students involved as well, because currently we're all engineers of some kind. But I know other teams on campus, such as our Formula student team, it's definitely something we'd want to move into in the future.
What are your experiences at EuRoC?
None of us personally have been, so we're all quite excited to go. The team has been twice. First year, I believe 6 members. They had a successful launch, successfully recovered the rocket as well. And then the second year was 2022. Rocket was a sort of evolution of the previous year's rocket. Sadly, didn't make it off the launch pad. There was some sort of manufacturing defect with the solid rocket motor, which was out of our hands. It essentially exploded, which destroyed most of the rear half of the rocket. So unfortunately, not only did we not get any data, but we also lost the rocket. That was obviously a bit disappointing, but we're hoping to come back stronger this year. We've had a year away from EuRoC, so it should be good. I guess expected difficulties because there's not a lot of experience going to EuRoC in the team. We've never written the documentation for EuRoC, so that'll be a lot of effort, but hopefully it will pay off. We've got support from some ex-team members who said they're willing to give us advice for that. I mean, the other challenges are, as every team faces, various issues with just making sure everything works on the day. Some of the modeling we've been doing has been indicating that the temperature on the day might have an effect on our final altitude. So we'll see how that goes. Obviously, you can't predict that.
The way that we have designed our vehicle, we're also liable to take part in final design reviews in quite a few of our subsystems. So that's also something that the team doesn't have any experience with really. So we're quite keen to make sure we do a good job at those final design reviews to make sure that the people at EuRoC are also satisfied that we're conducting everything safely and properly. Yeah,
it's an ambitious project. So we're going to have to prove to EuRoC obviously that the engine works and is safe, that we've tested our fuel tanks thoroughly enough. We've got an air brake system, so I think EuRoC requires some extra demonstration of that working. There's a number of other areas on the rocket that will need a lot of testing and validation. So that I think will be the biggest challenge. I think we'll all be quite happy if we get to the launch pad, and doubly happy if it makes it off the launch pad. So we're hoping to get to EuRoC this year, get as much experience as we can, come back even stronger next year and the years after.
What are your goals for this year's EuRoC?
Get to 9,000 meters is obviously, that's the category we are entering or planning to enter. So if we get to 9,000 meters, that would be great. A smooth flight is really our main goal. Getting to 9,000 meters would be a bonus. And if we can recover the rocket safely, even better.
It is with how much new work that has gone into the vehicle. It's been a tremendous effort from everyone involved. So just getting to the competition and getting off the pad would already be a huge accomplishment, and then anything kind of past that is just a great bonus.
Obviously, we're going to win, but it might not happen.
Yeah, but also we're very ambitious this year.
Yeah, it's a much more ambitious project. We're going to put a lot of effort into our sort of initial application and documentation and all the different reviews, just to really prove to EuRoC that we know what we're doing.
Do you want to join other competitions apart from EuRoC and Race for Space?
Yeah, I mean, so obviously we've been to Spaceport America Cup in the past, and I'm sure we'd love to go again. That's more of a budget issue than a sort of wanting to go issue. We would really like to see a competition in the UK, because obviously only having one opportunity to launch, i.e. at EuRoC, isn't ideal. It's not a lot of testing time. So we know of other teams that have launched in the UK. There are a couple of spaceports. There's one up in Scotland, one in Cornwall, although I'm not sure they do vertical launch. But there are a few spaceports around, and we would like to see maybe teams could get together.
There's one in the Midlands as well.
Unfortunately, the main UK competitions like MAC, they don't really. Our vehicle would certainly be too powerful for that kind of competition. So it would be great to see something that kind of a competition that can deal with the same kind of classes vehicles as EuRoC in the UK, for sure.
Yeah, and I think there's a market for it. As we said at the beginning, there's a lot of teams in the UK building rockets of a similar size to ours. I think an opportunity for us all to launch against each other would be really good. But we'll see. I'm sure one will happen in the future. There's been talk about it. I know when COVID happened, there was some chat amongst the UK teams about getting a competition going. It never happened, but might happen one day.
How do you see rocketry evolving in the future?
We hope to see that a move away from that classic aerospace company mindset. So the very slow moving, very tried and true methods, which are very safe, but the existence of companies like Rocket Lab or SpaceX show that you can iterate a lot faster. We kind of hope to be part of that. As you said, because of how budget constrained we are, we're using a lot of slightly more novel manufacturing techniques that are a bit cheaper, like 3D printing and things like that. So we hope that kind of it will move more in that direction as more and more teams and companies want to get involved in it. The application of those kinds of manufacturing techniques are a bit more widely adopted in the industry.
Yeah, I mean, 3D printing is the big one. Obviously, there's big companies in the industry doing it, like Relativity Space, smaller teams. We haven't done any metal 3D printing yet, but it's definitely something that's in our sort of scope for the future. But there are other teams in the UK and in Europe that are doing it. I'm pretty sure the Imperial rocket team has got some 3D printed parts on their rocket, which is cool, as well as Sheffield. Yeah. So that is, I think, the pretty clear direction that the industry is moving.
But also, I guess, developing hybrid propulsion.
Lots of teams now are, at Race to Space, it's easy to see more than half of the entrants are hybrid vehicles, some biprops. So I can imagine that competitions like student design motors will also become more normal over time.
And I guess the other thing is more environmentally friendly manufacturing methods. Obviously, we've been looking at the fuel that we mentioned earlier, so beeswax, sort of as a replacement for paraffin wax. It would be nice to see teams sort of and companies moving towards more sustainable materials, more sustainable composites and manufacturing methods. I think there's a lot of research happening in that area.
How much do you build your rocket yourself, and how much do you outsource to sponsors?
We're manufacturing either by the university workshop or us ourselves. Almost every we're manufacturing the fuselage, we manufacture the air brakes ourselves. All of our bulkheads were machined in house. The only thing that isn't really going to be manufactured by us is some laser cut metal parts. I believe
the Aerospike as well.
And the Aerospike will also not be manufactured by us. But we wanted to get our fuselage laid up. So we're doing lots of it, which is great because it means there's some very hands-on things that lots of people can get involved with. So when we go to lay our fuselage, it's more than 2 meters long. That will have lots of people involved in that.
Quite fortunate that the university technicians are willing to spend their time manufacturing stuff for us for free. So we buy the materials, give it to them along with the drawings, and they manufacture it for us. So that's really useful for the sort of metal machined parts. And they're obviously very experienced, and it's done to a very high quality. And then we've got our own workshop that we do a lot of the work in.
And the interacting with the machinists, it's one of those things that the members really get to learn a lot from. A lot of the time, the machinists know far more than any engineer does about what's possible to manufacture and how you can make your designs better for manufacture. So,
And they'll just tell you if it's not.
and they'll tell you if it's not done properly. So it's a really good opportunity for a lot of the members to learn how to design things well for manufacture.
Another thing actually that we forgot to mention, the nose cone.
Oh yeah. Oh no, I can't.
So this is our nose cone. It was bought from an American company. It was bought from Public Missiles a couple of years ago. That's the nose cone we're using, and that's it's fiberglass as well. But we didn't lay it up ourselves.
But also for manufacturing, we want to get more first and second years involved so that they can have a hands-on experience and then carry on with the knowledge they will have learned for the future years of the rocket, because we're graduating this year.
Yeah, want to try get them. Well, give them some skills that they can use in future years for the rocket. We're also in the avionics. We're doing most of that ourselves. Apart from we've got supplier helping us with some sensor systems, but otherwise everyone's doing we've got a team doing the programming and the component selection and design themselves.
What software do you use to design the engine and the rocket?
All of the analysis is done in Mathlab, so that's things like the engine design. Our engine lead has built like a full simulation systems engineering model in Mathlab, and then sort of various other pieces of software. So there's some analysis being done in ANSYS, so that's structural analysis on things like the fuel tanks,
As well as
and CFD on the fins and the nose cone and inside the engine, and also thermodynamics analysis inside the engine. That's all in ANSYS. And then the main CAD design and some other structural analysis work is done in Autodesk Inventor. So that's sort of from a design point of view, MATLAB, ANSYS, and Inventor.
I think we also have someone working on Nastran for structures.
Yes.
Yeah, Autodesk Nastran, Inventor Nastran as well. In terms of other software, there is a guy on the team developing a sort of flight simulation, flight dynamics model in Fortran. Hopefully, probably won't be done in time for EuRoC this year, but in future years, the team can use that as a development tool. We've had similar softwares designed in MATLAB in previous years. EuRoC requires the use of Rocketry, so we'll use that as well for flight dynamics planning and simulation.
What electronics do you use in your rockets?
We're not doing a custom PCB this year, although that was done 2021 and 2 rockets. So it's probably something the team will come to in the future. We're not doing it this year just due to time constraints mainly. Sensor package is being developed in partnership with a company called 3D Photonics. They're going to be helping us to design some of the sensor systems that we can integrate into our avionics. And then the main system is just
they're Raspberry. So the main system runs off Raspberry Pi Picos, and I think a handful of them will be used. So one will be dedicated to the air brakes. One is dedicated to the engine throttle control, and then one is dedicated to the recovery system. Alongside that, we have the CATS Vega, which EuRoC uses for their apogee measurement for the competition. But we'll also be using that as our redundant flight computer to activate the recovery system should it be needed.
What do you want to use for your launch rail?
We'll just be using the EuRoC supplied launch rail. The rocket will have some rail lugs mounted to the side on hard points that will slide along the rail. So not doing anything fancy there. Other ground support equipment, we'll have a telemetry station, uplink and downlink to the rocket, which is still a work in progress. And then, various sort of filling systems. Obviously, EuRoC requires that we can vent the rocket remotely. So that's another system that we'll have.
We will have on-rail charging.
Yeah.
Although I don't know how that's implemented. But yeah, that's something we will do, so we don't have to worry too much about the batteries running out whilst we're on the rail.
What will you use for your recovery system?
The recovery system is the subject of my final dissertation. We're going to go for a brand new, it's going to be a completely mechanical deployment system. We'll be using 2 discrete parachutes rather than a reefed system, neither of which will be parafoils, unfortunately. Just conventional parachutes just to simplify the design slightly. We'll be using aero staging of the parachutes rather than, say, like a mortar system.
Yeah, the team, we researched using a controlled parafoil actually last year for payload recovery. We're not using it because this year we don't have a deployable payload, but it might be something we look at in the future.
Mm-hmm.
Yeah, otherwise I think it's a It's a fairly standard parachute system, but it's different from our previous design. The previous design used a pressed gas mortar system, which we're not using this time around.
Do you know Kerbal Space Program?
I've definitely played it, not recently, but I used to play it in the past. I think it's really good.
Yes, same. I definitely used to play it a bit. I was pretty terrible at it though,
Yeah.
so I don't really know what that says.
Yeah. It was nice. We had a spacecraft engineering module as part of our degree. It was nice that some of the things that showed up in the module I've seen in Kerbal Space Program before, and I was able to be like, oh, I've done this. But I haven't played the new one though, newish.
How far have you gone in Kerbal Space Program? Have you reached, do you know?
I was not very good. I tended to just make lots of different rockets, but never get very far with them.
I only got to just about to orbit. I was a big fan of making very unstable vehicles.
Yeah. Our engine guy managed to remake the International Space Station though, so at least someone on the team knows what it's doing.
Yeah, I remember I once made a space station that orbited around one of the moons of Joule.
Yeah,
That was
that's
some time
impressive.
ago.
That's impressive. Yeah, I know it is.
I later installed a mod which is called Real Solar System, because the
Oh,
Kerbal
yeah.
solar system is 1/8 the size of the real
Yeah.
solar system. And once I installed that mod, I was no longer able to get to orbit.
Yeah,
I see.
I remember trying that mod as well, and yeah, it makes everything suddenly a lot harder. You realize how much harder things are in real life. 'Cause, yeah, the delta V's required for normal Kerbal Space Program are like a quarter of what you need in real life.
Yeah, I was just barely able to get to orbit with the real solar system. And I was not able to get down from orbit because I used all the fuel to get up.
Can't even deal with it.
You have any announcements or dreams?
Get to EuRoC, fly with our hybrids. The short, I guess not short term, the sort of medium term goal is to get to EuRoC and fly. In the future, I mean, we've talked about doing a whole number of things, looking at biprop engines or staging, going for the altitude, the UK altitude record or something like that.
We've spoken about trying turbo pumps in the engine. There's all sorts of things that I think everybody on the team would love to do, but we're just a little too spread thin to try a lot of them.
But
So
also,
no-
we need to find a name.
Yeah.
Yeah, we need to find a
So
name.
if anyone has a good idea.
You have to name the rocket.
Yeah, we can't agree on one.
Yeah, we'll come up with one eventually. Yeah, at some point when we finalize the design, we'll share it on LinkedIn and we'll come up with a name.
You can call it like a Bath Rocket 4. Or I don't
We have to think, 2 years ago it was Phoenix, and then Phoenix 2, and before that it was Mallard, which is a type of duck, and then Mallard 2. So there's
There's a bird theme.
I guess that you have many birds to choose from.
yeah,
It's true.
that's
Yeah.
true.
A lot of the bird names are already rocket names though,
Yeah.
and we can't really steal them.
Can't take something that's already taken.
I guess that chicken isn't the best name for a rocket.
I want to call it.
The chicken one rocket. You can choose from many birds.
It's true. We've got a lot of scope.
You can go on Wikipedia, search the list of bird species, and start scrolling and see if you find one that you think is good for the rocket.
No, definitely.
But also one of the symbols of our university are ducks. So
Yeah.
this is why the
Right.
previous rocket was called Mallard.
We should go goose.
Oh yeah, we should go for goose.
Well, there are many birds that you could call it. You could call it a duck.
I mean, some of them like
Eagle?
eagles already taken.
Was albatross taken?
An albatross is not-
One of the names of the concept rockets was the Mighty Duck.
The engine was called Hornet, so Yellow Jacket was thrown around for a little while.
Do you have any advice to young rocketeers?
Be interested and keen. Try get involved in projects like when you go to uni. If they have a rocket team, get involved with as much as possible. As we said earlier, there's a lot going on in the industry currently. So there's a lot of opportunities out there if you sort of put your name out.
But also, as you said, if they go to university and they have a rocket team, then they can get involved. But if they don't have a rocket team, then they can be the pioneers in their university and
Start one.
start the rocket team.
And the good thing about especially like this scale of rocketry is that you can really collapse it down to a 100-meter rocket if you really want to, and a lot of the principles are still the same. It doesn't matter how small you make it, you're still using the same maths and all the same ideas. So yeah, even if you're very young, just build something. You might go wrong and you'll learn something.
What are your favorite space movies and space YouTubers?
Space movies. I really liked. There was an Apollo 11 movie that was released a few years ago that only used actual footage from the time.
Mhm.
That was excellent. Highly recommend that.
So Apollo 13 as well. That's a really good movie. Interstellar, a classic that everyone likes.
Well, for me, that would be October Sky.
Yeah.
Yeah.
Oh.
Okay.
So if you haven't watched it, I recommend.
And how about YouTubers? Do you like BPS Space, everyday astronaut.
I love you.
Yeah, Scott Manley, very informative. Everyday astronaut. You should watch quite a few of his videos. He's good.
I mean, BPS Space actually really helped me know how to design a lot of the stuff for the first time. A lot of the things, if I wasn't sure they were possible, he'd done them on his channel. I was like, yeah, it's all feasible. As you say, everyday astronaut as well. That's kind of where I learned most of the stuff I know about Rocketry.
Yeah, he has some really good videos and articles on his website about how sort of liquid engines work, all the different.
I would recommend the Galactic Gal, the
Yeah.
female representation in the industry.
Yeah, no, he's good as well.
Do you have any questions for me?
Yeah, I guess what have you been working on currently?
Well, recently I've been doing a bit of electronics. A rocketry-related project that I've been wanting to do from a long time is building a liquid rocket engine.
The dream.
Yeah, I found that probably the hardest thing for me is finding a good oxidizer.
A lot of the teams here use, but it's really hard to buy because it's very tightly controlled. Is high proof peroxide, but it's quite hard to buy because it's quite tightly controlled.
I was thinking of using molten potassium nitrate. And it's a dumb idea, but I have a 25 kilogram bag of potassium nitrate, so I should use it someday.
I'll stay away from the most rocket engines. They got good performance though.
So are you part of a team yourself?
A team, I've tried to make one, but no, I'm not.
Join our team.
I'm afraid I could not help with manufacturing because I'm a bit far away. Using liquid potassium nitrate as an oxidizer is quite a dumb idea. I mean, I don't even know, I'm not sure if you could use like copper pipes or if they would oxidize.
I have no idea. I have read about. Yeah, I don't think I've ever seen them outside of theory.
It must be quite difficult to get all the pumps and the injection working properly as well.
I would not have any turbo pumps for sure.
Yeah, pressure fed only.
Yeah, I would like pressurize it with air and hope it works. I mean, pressurizing the oxidizer with air isn't that dumb. Pressurizing the fuel with air is a dumb idea.
We don't on the current design, but we have looked into using a pressure. We've actually got a pressure tank. We were going to use nitrogen as a pressure.
However, I don't have any pure nitrogen.
Yeah, easier to get hold of probably than the potassium nitrate.
The potassium nitrate is actually quite easy to find. I bought it as fertilizer. The thing is that an engine with liquid potassium nitrate would very likely be hypergolic.
Yeah,
because I tried melting some potassium nitrate, and basically whatever you put into it, it immediately starts burning.
Means you don't need to have an igniter system.
Yeah, I mean, ignition is actually a problem.
It is.
Yeah,
we had a lot of issues.
We've had a lot of issues with it. Yeah, in our test, we just used essentially like a blowtorch. But obviously, we can't do that on the actual rocket, so we're using mini solid rocket motors to ignite the engine. We haven't done any testing yet on whether that would work. We've looked at electrical ignition as well, but it's not really feasible. Yeah, it's quite a tricky problem.
Yeah, having something be hypergolic is really helpful in that sense.
It isn't the safest thing, though.
No,
and
not the safest.
And usually it's very toxic.
Yeah, I don't think EuRoC allows it.
But potassium nitrate isn't really toxic.
I mean, the classic.
Yeah, the classic ones like hydrazine.
It's very toxic.
Or they use fuming nitric acid.
Yeah.
As an oxidizer. That's also toxic.
Yeah.
And very hard to store.
It is.
Yeah.
Also, it likes decomposing. So you have to keep it cold.
Yes, no, very much so.
And the fumes like to dissolve your container.
Looking to transport around, especially if you're going from the UK to Portugal for a competition. It's quite hard getting these things across the border.
If you were to make a bi-liquid rocket engine, what fuel would you want to use? Ethanol?
Yeah, I think ethanol is probably the most commonly used one by teams. I mean, there'd be a lot of kind of going down the same. I mean, a company like Orbex is doing, and the university would we could use something like a biopropane as well. And that would be good. It's nice and renewable. I'm not sure though with biopropane if there would be storability issues in keeping it as liquid.
Propane?
Yeah, like a biopropane. So as a product of waste and stuff like that.
I mean, you can buy like a tank of propane, like the one for blowtorches. That can be stored for months, so I don't think that storage could be a problem.
No, it's true. It's true. It's not something that we've ever really considered or even looked at.
Though many times it is easier when both the fuel and oxidizer are both liquid or both gaseous.
No, it's true. So if we're using gaseous propane and then something like peroxide, we could pass the peroxide over a catalyst to make it decompose. But I'm not sure. Never thought about it.
Or you could just use ethanol and nitrous oxide like all the other teams. Actually, the real team used methanol.
I know some of that. I think one of the Imperial College teams in London. They're using liquid oxygen, I believe, this year at racing days.
The VAR team was using liquid oxygen. But
Not Imperial.
well, using liquid oxygen adds many complexities.
Their engine's really exciting though. It's I believe 25 kilonewtons. It's a very large engine.
25 kilonewtons is quite a bit.
Yeah, no, they're using turbo machinery and stuff. So it'll be very fun to see how that goes.
Yeah, they're coming to race.
Yeah,
They're using turbo pumps.
yeah.
What type of cycle?
Oh gosh, I have no idea.
You'd have to ask them. Yeah, we've not seen their engine sort of being used in person yet. But,
we've just read their
seen some
concept
videos.
presentation.
Yeah, there's a few different teams experimenting with biprop engines in the UK.
Hopefully, we'll be one of them one day.
Thank you for joining and being here.
Yeah, thank you.
Thank you.
Thank you.
Yeah, you can find us on sort of LinkedIn, Instagram.
Bye.
All right, so.
Bye.
Bye.